Hello, good afternoon, everyone. I hope you're doing fine today, and I hope you can hear my voice well. We'll be starting our today's class, so please make sure that you've joined in. You're set to start the class, uh, and let's wait for a couple of our students to also join the class. Um, So please go ahead and let's start with discussing what we've been learning yesterday. So please go ahead and write in the chat section, also in the comment section, what we've been learning yesterday. Good afternoon, everyone. The class has started. So let's start discussing about what we've been learning yesterday. And you guys can keep on writing down what you remember from the things that we learned yesterday, and then we would start today's class. So I saw comments of you, couple of you saying about pull down resistors and pull up resistors that we've been learning. Yeah, that's correct. And also Arduino and Tinkercad. That's a very general description. Yesterday we learned about connection of Arduino with breadboard and making traffic light code property. Good. Okay, so let's revise on the pull up and pull down resistor, and then we're going to proceed with the um, today's class. So today we're going to see how we can be able to connect different kinds of sensors, servo motor, piezo, and also ultrasonic sensor. These are the things that we're going to do, and then we're going to start the project development. So for the project development, we're going to group you into a couple of groups, and through that group, you'd be doing one project using Tinkercad. So in Infnova trainings, whether it's a 3 days or 1 day or 1 week on 1 month, 4 months training, all in all the training you're demanded to do a project. So it's a way that you apply your knowledge on what you have learned, based on what you've learned, and that would actually enhance the things that you've been learning. So accordingly, we'd also apply this in your lesson about Arduino. So tomorrow's time, most of it would be dedicated for project development, and part of the time from Friday also for you finalizing your project. And on Friday, we'll reserve 1 hour for your project presentation and also exam time. So the formal class that we're going to have is going to be today. And tomorrow, just a bit of a class, and mostly for project development and mentorship online, supporting on what you've been doing. Okay, saying that, we'll discuss more about project development after this later on. Okay. Let me share my screen. Okay, so yesterday we've been discussing about pulled up and pull down resistor. So we use pull up and pull down resistor so that we can actually use signals like push buttons. So push buttons are connected diagonally. That's how you should do it. And so the other thing that we've been discussing is for pull-up resistors, it's normally connected to 5 volt. It's pulled up to a higher voltage. And whenever you press this button, the current will be coming to have a decision between the 2 points. So it chooses always, current chooses the better paths where there is less resistance. So since we have a microcontroller here with a couple of resistance, it's not going to choose here, it's going to go ground. So whenever you press the button, it's going to be 0. If you don't press it, it's going to keep on hanging on 5 volts. And the other one is a pull down resistor. So when it's a pull down resistor, it's actually connected to ground with 0 volt. And whenever the switch is on, so this volt is the 5 volt comes, and the current would have to make a decision between the pull down resistor and the microcontroller. And obviously it's going to choose the microcontroller because it's got a smaller amount of voltage. So the most important use of pull-up resistor or pull-down resistor is for a solid input. So if you don't use pull-up or pull-down resistor, the challenge is that the fact it doesn't actually, you're not sure about which voltage it's reading. Sometimes we read noise. Okay, there could be noise if you just connect the button. Sometimes there are noises when it's on and off. There are hanging voltage like 2 volt or maybe 1 point something volt. or 3 volt. This usually creates errors that you cannot fix with a code. These are hardware based errors. So to avoid these kinds of error, it's always important to use pull down and pull up resistor. Look, for pull up resistor, it's either 5 or it's going to be 0. So there is no hanging voltage in between. Maybe from 5 voltage, there is a couple of voltage drop here, but we're going to read high or low very precisely. Likewise for the pull down resistor. So we use pull up and pull down resistor whenever we use buttons. You don't make sure you don't use the 5 volt and then directly put it in a signal. That way it's going to be noises that you're going to read, and it causes high disruption in your operation regarding the project. Okay, so we've done a circuit trying to understand about pull up and pull down resistor. So what we've done here was, so we have 5 volt here coming in, it's connected. So it's a pull down resistor because look, we have the resistor here connected to the ground, and it's connected to 5 volt. I mean, to the microcontroller, which means the microcontroller's pin 2 is at always ground. Okay, this point is at always ground because of this pull down resistor. Whenever we press this button, what happens is voltage comes in and then goes through this. And the voltage have a choice to go under the resistor, one option. The other is directly to the microcontroller. And it's better to go through the microcontroller, so it's going to make it a pull down resistor. So yeah, let's simulate it. So on the serial monitor, you can see that it's actually a pull down resistor. It's always reading 0. And if I turn this on, it's going to be 1. Okay, so let's use this logic to turn on the LED on the pin 5. So on pin 5, we have an LED. So when I press the button, I would like the LED to light up. So what I can do is the following. Let's stop the simulation, and I can say if digital read and button state, I think, yes, this is the variable that is holding the value. So button state, and I can say input. We have actually defined it to be input is equals to high. Then what we're going to do is the following. So we're going to say digital write LED, it's small, LED is equals to high. Okay, else if it's not pressed, else digital write LED low. Okay, let's start simulating this. I remember someone asked previously, how do we save the codes that we've been writing or the circuits that we've been doing on Tinkercad? You don't have to save necessarily if you just have done this, and it's going to save it. So this is, for example, I give it a name of pull down resistor. Pull down resistor simulation. Okay, let's run the code. Ta-da! It shows that it's burned out. That's because we've connected it directly to the LED. We need to put a resistor in between. Let's close this. Necessarily, I don't think we need to have this resistance. Pin 2. Let's give it a color of orange. And for this one, let's make a copy of this. Pin 5. Let's give it a different color. Okay. Let's give it a resistance of 220 ohm. Let's run this. No. So when you press it, it turns off. When we don't press it, it's actually on. So let's check our code. Look, what's happening is it only turns off when I press that button, which is the reverse of what we are doing. Okay. So originally, maybe it could have been. No. It's usually 0. So I should say this. Low, and this one. I think the mistake comes from the bracket, maybe. This read button, we have the bracket closed here again. Yeah. Let's simulate this. So if you want it off, all you have to do is make this low. So now it's off. When I press the button, it turns on. When I press it off, it's off. Okay. So you can also implement this using pull down resistor. So take your time to actually implement this. Let me just send you the code in the circuit, which you can keep on trying it. So there you go. In the community section, I've sent the code. Also, if you're looking for it in the Telegram group, I did. And the circuit. But you can always find it from the activities. Okay, so the other thing that we're going to do today is another project. Let's go to Tinkercad again, and let's see about piezo sensors. So piezo sensors are ways that you can produce sound in your projects. So whenever you're looking to have a certain type of sound in your project, use piezo sensor. So let me create a new design circuit. And I'm going to bring my Arduino Uno. I just got a news that for some of you who haven't filled in the grouping form, please go ahead and fill this. It's important that you actually do your project. I'm going to send this form to you in the chat section. This is going to be your last time to do it. If you miss it, then it's going to be difficult for us to group you. So please make sure that you do this. At the end of today's training, we're going to dedicate 10-15 minutes for project discussion. Okay, we need piezo. Piezo, this is piezo, okay? This is something that you usually know from your Christmas gifts, gift cards. When you open them, there is some kind of music doing device like, and in the early days, the first mobile phones used to have this as a speaker, the piezos. And we need board. I would prefer the small one. I may put this here. Let's bring this here. And we need the 5 volt. And ground. Let's make this straight. So this one straight. Okay, done with that. All right, so this color should be, this one should be black, this one should be red, and next up is connecting the piezo with the Arduino. So to do this, we are going to connect the negative terminal into ground. So this is negative. We put it to the ground, and the so let's give it a color of ground, that's black. And for the positive, Let's connect it into something, or one of the say digital signals. So 3. Okay, so I'm going to give it another color. Now let's start the code. Text. Okay, so as usual, when we code, we first give the pin with a variable. So I'm going to say int buzzer, and maybe it's connected to pin 3. In setup mode, we're going to say buzzer is an output. That's our setup, nothing more. So we're going to create some kind of sound, very easy sound, and we keep on updating it. So let's create a sound. Let's say, so to use in a buzzer sound, what we do is we say tone, and then we give that specific buzzer pin. So it's buzzer for me, and then you give it whatever value that you like. It's in an audible frequency that the human can hear. So I'm going to give it, for example, 200. And let's run the code and listen to what happens. We have an error because of a semicolon. I wonder if you guys can hear this. Someone confirm me. Did you listen? Did you guys listen to what happened? Anyone who listened? Someone said at the chat, is this the daily attendance? No, it's not a daily attendance. What I sent is the grouping for. So if you haven't filled in, please go ahead and fill it. Necessarily for something that you filled in, using the same email, it shouldn't make you fill it in again. Okay, did you guys listen to the noise that came out? Anyone who listened? So due to the streaming challenge, I don't think you can listen to the voice that I'm making, but I'm going to record it with my phone and send it to you. For example, I'm going to do this and tone. I'm going to say buzzer and maybe 800. And let's have a delay of 500. Let me copy this. Let's give it a delay of 500 again. Let's put our semicolons. Okay, let me run this. You know, I come from Python background. I don't do semicolons. So I'm gonna have to record this because you guys can't listen to me or the voice. We have to check the streaming activity. So anyways, I'm going to record it on Telegram. Okay, now I have sent it on Telegram. you may hear it. Actually, I can also. I think you can hear it now. Me. Uh, so this is one music that I have done. So can you guys start to experiment the musics that you can do? So I you can do loops. For example, let me do one example chord that I've done. So this is the chord. Let me replace this with the chord that I've done. What? Okay, okay. Okay, I believe you can listen to the audio that we're going to send after this point onwards. Um, okay, let's see what the error. Okay, it's because I've written it buzzer. Well, you can see that. So this is like if you're doing, let's say, an electronic car, and you can do this. Okay. So I believe I've sent the previous code. Oh, I didn't. So let me send the previous code, which is much easier to do. And I'm going to also send this code. Okay, I've sent the code, and also let me send you the circuit. You guys can start to experiment this. I would like to listen to the type of melodies that you came up with. I'm also going to do another melody until you guys actually have done. I'm going to make you listen to the melody that I've done. For those of you who haven't understood my question, um, you guys said loud and clear disturbance. It's a good thing at least you're listening. It's okay. Anyways, so you go ahead and do one some kind of noise using the piezo sensor. Okay, guys, I see that a lot of you have tried to do something else. Let's go ahead and listen to the things that you have done. I understand that it doesn't come up with a perfect music on on a Tinkercad simulation, but if you're using Arduino hardware, then it's going to be actually way much better. So someone have done this. It's interesting. Also appreciate it if you can send the circuit. Good. Okay. Now that we have done Arduino, Piazzo, we're going to learn a couple of sensors together, and then we are going to start to connect them together, right? Let's also see about servos. Does anyone know about servo motors? Does anyone know about servo motors? Anyone who knows about servo motors, please go ahead and write in the chat section, also in the Telegram group, whichever way you prefer, write about the servo. What is a servo? What is a servo? Can someone say about servo motors? What you know about servo? Okay, Highlab said servo motor is used to control speed rotation of a robot and other things. That's correct. Motor controlled by a specific degree. Precisely. Ashi. So let's implement a servo using Tinkercad. Let me rename this. Maybe I'll rename it later on. Okay, I can't rename it. I'll rename it later on. Let's create a new circuit or create a new design. Circuits. So I'm going to bring in Uno, Arduino Uno, then servo. This is the servo that we're looking for. And let's also bring in word. I'm looking for the small word. I'm going to put it here. And as usual, I'm going to connect a 5-volt of the board to the Arduino and red. And we're going to connect the ground. Here, and we're going to make it black. Yeah. Okay. So now that is done, and we are going to connect these wires. Look, for the servo, we have 3 wires, okay? The first one is power, the other one is signal, and the other one is ground. So the ground goes to the ground. Maybe let's rotate this the other way. Okay, so let's connect the ground to the ground signal. And the power to the power signal. And let's bring in the signal cable to one of the pins. Let's straighten this up. Okay. So for your project, I expect straight wire and everything, okay? Readable connection. Okay, so I've connected it to the servo. So I'm going to write the code now. So as usual, I'm going to give the servo pin to attach it, but there is something that you need to be aware in the coding section. Sometimes some sensors or some components in the Arduino they require you to import a library. That is a library that is connected to the specific sensor so that you can be able to use that sensor. Most sensors screens, they have their own library. So you download that library and you connect it in the actual Arduino work. So here, all you have to do is once it's already installed for Tinkercad, all you have to do is just call it. So I just say hashtag include. So this is going to include me the servo library. So I'm going to say servo.h. So this includes the servo library. So you can comment it as includes servo library. Okay, and next line, what we're going to do is we're going to attach the, we have inside of the void setup for servo, we need to use servo.attach. So I say servo.attach, and which pin is it? It's on pin 2. So I'm going to say pin 2. This is going to attach it to the servo. And next up, I'm going to say servo.write and give it the degree. So originally we need to for the servo to start on 0 degree. So I'm going to make it at 0 degree. Once it's 0, before it starts, it's always good to have a delay, which is used for calibration. So it's going to delay 1 second before it starts its operation. And then in the actual loop, let's remove this code for the previous one. And I'm going to say servo.write, and you can write whatever degree that you want. I'm going to say 90 degree, then I'm going to give it a delay. I'm going to give it a delay. So I'm going to say delay 1000, and later also servo.write. I'm going to give it 0 degree and delay 1000 or millisecond or 1 second. Okay, so let's run the code. I have errors. So oh, we have just included the library, but we never actually started the object that holds the library. So I have to say servo, this is the actual object in the instantiation. We need to create that instantiation saying servo. The one that I'm saying here, servo everywhere, the instantiation haven't been done. So I can do this now and it shall work. Ta-da! So you see that now the servo is going between 0 degree, 90 degree, 0 degree, 90 degree, 0 degree, 90 degree. It keeps on doing this. But you can play with it. For example, I can put in a for loop and for it to continuously increase by 1 degree, I can do that. So I can say for using a for loop, so the way that you write for loop in C++ is for I int I is equals to, let's say, 0 degree originally, and then we want it to go until I is less than 90 degrees, and then we're going to keep on I++ adding I. So let's do this, and so let's create servo.write I, the value I, and we give it a delay. Delay, and maybe 1 second is too much. If I half a second. Actually, it's okay to have 1 second. Let's remove this code and run this. Delay. You see that it's moving little by little, okay? Every 1 second we have a movement. It keeps on rotating from 0 degree until 90 degree, moving every 1 second. So let's make it a bit faster, right? So let's probably give it like 300 milliseconds. You see that now it's rotating every 300 milliseconds by 1 degree until it reaches 90 degree. Okay, so let me send you the code and the circuit, and I would like to see what you guys have done. So there you go for the code. Also in the chat. Okay. I'm going to send this also in the Telegram group. Okay, so go ahead and start doing this. I'm going to rename this to be servo black spots. I'm going to show you about potentiometer. Servo black spots. Okay, you guys now start doing this. Let's have 5 minutes to do what I showed you, and then we're going to also proceed. Okay, guys. I don't see any of you have done the servo thing. What's the challenge? I would like to see your challenge. What's challenging you? Let me go through questions if you can write your questions. Someone said, why don't we use normal uh, motor modules? Of course, you can also use that, but the motor module is not geared. Look, for the servo, inside of it, there is gears. So that gear gives you a freedom to control in every single degree. But using a motor, it's going to be very difficult. There are techniques that you can use to control a specific movement using normal motors, but it's almost difficult or very difficult to control the degrees, each degree. So we usually use servo motor to control the degrees. And for rotations and everything, we use the motor. That is the way that we proceed in robotics. Any more questions? Anyone with question? Let's try this until 180, maybe if it goes. Shall I proceed to the next work? If you guys are okay with this. Okay. So someone said, let's proceed. Let's see. So I'm also going to show you another sensor that is known as the potentiometer. So potentiometer is, you can write pots, you can find it here, potentiometer. So potentiometer is a device like a switch, okay? You can rotate the potentiometer between 0 and a couple of ohms. So you change the resistance. While changing the resistance, you change the current. So which means you can have certain amount of values, analog values. Until this point, uh, we've been using digital values, but now let's try using analog values. So for analog values, that means you have a value between 0 to until 225, which match the exact of 0 to 5, okay? 0 to 5 is matched to 0 to 225, which means 0 is 0 volt and 225 is 5 volts. So anything in between you can find using crisscross methods. So this potentiometer, we can use it to control, for example, the dimness or the brightness of a light, or maybe even for our servo case, we can map 0 to be 0 degree and the maximum amount to be 90 degrees. And then we can map this for the rotation of our servo. Okay, so is potentiometer clear? If you have question, you can ask. Is potentiometer clear? I was expecting for answers. Is potentiometer clear? I expect this is clear. Okay, so for the potentiometer, we have, okay, so someone said, yeah, thank you. Okay, so for the potentiometer, we have three terminals, terminal 1, terminal 2, and wiper. So terminal 1 and 2 are the positive and the negative signal. So for a potentiometer necessarily, the terminal 1 and terminal 2, you can exchange it to be positive or negative, it doesn't really matter. Because internally, as I've said, it's a resistor. And resistors does not actually have any terminal. It doesn't really matter. For the case of LEDs, you remember that they have terminals, positive and negative. If you exchange them, it's not going to light up. But for the case of potentiometer, you can actually shift, and it's really okay. So I'm going to connect one of the terminal to be on the negative, the positive rail. By the way, I can also do this. I can connect it to the other terminal here. I'm going to show you this technique so that if you have a lot of wires, you can always use this. Okay, so I'm going to click this and connect it to this one, ground and ground, and I'm going to make it black. I'm going to also connect the other side. I'm going to make it red. So now this rail is all ground and this rail all is going to be 5 volt. So I'm going to make this black and the other one, the other terminal here, I'm going to make it red. Let's correct the wiring. And now for the terminal, we're going to give it in one of the analog signals. Let's say A2. So in analog pin 2, we have connected this. Okay, now let's go for the code. So what we're doing is we already have the servo, and we're going to connect the potentiometer. So I'm going to create the potentiometer here, saying int pot, and it's connected to I don't know if I have to say this. Okay. I'm going to say 2. Okay, let's proceed, and if we have an error, we will come back to this. And in the for loop, I don't really want this now. And inside of setup, I have connected my servo, then made my servo to start with 0 degree. I gave it a delay of 1000 milliseconds. Then inside of my loop, I'm going to say val, which is analog read from pot, and maybe I'm going to make it show in the serial pin. inside setup, I'm going to say serial dot begin 9600 for the baud rate, and print line, I'm going to say var. A lot of error is going to happen here, here, here. Val is not declared. Okay, I have to say int. Oh, it's printf. Oh, it's not necessarily we have to say serial because it's in a serial, so yeah, it should work. Okay, so let's go ahead and open up serial monitor and see what happens. Look, so I don't know if you can see this well, but you can see this is the serial monitor and this is the potentiometer. Let me make them closer to each other. Look, as I turn on the potentiometer, the value increases. Okay, the value increases and increases. The maximum value that we have is 10,000, 1,025. So something that I've forgotten, I have mistakenly said probably is it matches 0 volt with 0 volt and 5 volt with 1023, 1023. That is 1 kilobit. Yeah, 1 kilobit. So it matches with 1023. So as I keep on decreasing, it matches, for example, if it's 512 around here, 500, yeah, this is going to be 2.5 voltage, okay? So it's a directly proportional way that it's doing. Now that we have found the values, let's go ahead and connect this with the movement of the servo. So when it's when the reading of value is 0, then it's 0. Whenever it's 1023, 1023, it's going to be 90 degrees for the servo. So there is a matching function that does that, and we can be able to do that. So that function is known as mapping function. So I'm going to say once we have read the value, I'm going to say the val is equals to map so whatever the value that it's going to read is going to match between 0 and 1023. This value is going to correspond to 0 degree and 180 degree. Okay, so we have a value, and that value is going to correspond to 0 to 1023, right? The value is between 0 and 1023. This value that we found is going to be mapped to 0 and 180 degrees. That's what the mapping function is doing. And I'm going to say my, so the servo I have created is servo dot write, and I'm going to put that value. So this val have been updated. The original read val is there, and then it's mapped, and now it's written to the servo, mapped to a degree. So 0 means 0. If the value is 1023, it's going to be 180 degrees. If it's 500 something, 512, it's going to be 90 degrees. Okay, so let's run this. So now you see that it ran to be here. Look, when I start moving the servo, the potentiometer, the servo moves along this. Okay, now we saw two projects. The first one, when I press a button, the LED lights up. That's connecting two sensors. Now also we saw connecting two sensors. The first one is the potentiometer, and when I move the potentiometer, the servo also moves. Okay, you can see this. The servo is also moving. So when it's 0 degree, the servo is going to come also 0 degree. So when it's on the maximum degree, that's 1023, the servo is going to go to its maximum, which is 180 degrees. Servos cannot move beyond 180 degrees, okay? Keep in mind about this. So if I do any random number, then it's going to match it by the mapping function. So Dave Sami asked, is this a digital analog to digital converter? The mapping function? So the mapping function is not digital to analog, not analog to digital converter. It's trying to map the values. Okay, I think this question raises a good thing that we can explain a little better for everyone else. So there are two types of converters that we usually use. There are two types of converters that we usually use. The first one is digital to analog, and the other one is analog to digital. So digital to analog converter. So this is digital value originally like 0 and 1, and it's going to convert it into some analog value that goes between 0 and 1023. Okay, so anything in between will be mapped. So 0 is 0 and 1 is 1023. So mapping is done accordingly, and anything in between is going to be the values in direct proportion. So whenever it's a dark digital to analog converter, so it tries to find a threshold in between let's say above 3 volt, it's 1. It's going to if it's trying to convert it into analog value. Necessarily, if it's trying to convert it into analog value, this is not 1, it's 5 volt. I'm sorry. This is a 5 volt. So 5 volt, but necessarily it's 1, 0 and 1. But internally, the DAC converter would try to identify this, trying to convert it into analog specific values between 0 until 1023. But whenever it's analog to digital converter, it's between 0 and 1023, and it's going to map it into 0 until 5 volt, or 0 or 1. The output should be 0 or 1. Okay, so for digital, we have 2 values only. Either it's a 0 or a 1. So it's going to, your analog to digital converter, it's going to actually trying to find a threshold in between, like after 3 volts. After 3 volts, it's going to be 1, and below 3 volts, it's going to be 0. So it really depends on the kind of ADC that you're using. But the map function, it tries to resemble that, but it's actually different, okay? So the mapping function, what it does is 0 maps with 0, and 1023 maps with 180 degree. You can use this for any of your situation, okay? Necessarily, it's not for the servo case only. You can use it for any of your different purposes. 0, 0, and 1023 maps with 180. Okay, so anything in between will be mapped on a scale. So if I put it in a diagrammatical manner, so the mapping of the, let's say this is the degree that is going between 0 and 180, and the other one, let's say, let's use another color, is the analog pin. The analog pin, okay, that goes between 0 and 1023, and mapping would be done anything in between. So 0 mapping with this degree, and 1023 mapping with 180. So any point would be mapped like this. I hope it's clear now. So the mapping function is not a digital to analog converter or analog to digital converter. It's necessarily trying to map. This is a mathematical function. Okay, that said, someone said, please send the code. Okay, let me go ahead and send the code. Until then, please send out, Dave, maybe send out the grouping for. So as I describe about what the project is, we'll also send out an attendance in a bit. So maybe Nati, can you go ahead and do the attendance and send it to us? I send it in the community section. Day 3 attendance. Okay, so I have sent the code in the chat section in the Telegram. You can always find it from there. Okay, so as Dave and Nati sends the attendance in the grouping form, I am going to describe what you're going to do about the project. So maybe after this, I'm going to show you one more thing tomorrow, and the rest of the thing is going to be mentoring you to actually realize your project. Okay, so you're going to have a demo session of your project on Friday, but on Thursday, mostly you're going to use the time for development. Maybe I'm going to use 20 minutes or something else for showing you. All right. So the project that you're going to do is not something extremely big because you don't have that amount of time, or not something very small because you can challenge yourself to do something better. So the project is going to be any idea that you like. Maybe you would like to do, I don't know, a game, some kind of game, like using LEDs and anything else. Or maybe you're trying to create a moving device with the power that you have. If you are having Arduino, you can do the hardware one. But since you are in a different part of the world, it's going to be difficult to do a hardware project. So for the hardware actual project, we have in-person trainings in our space where you have a couple of more design trainings included in here so that you can craft the design that you like the hardware design, and then you can do something even amazing, including the hardware casing and everything, and also the electronics, the coding and everything. That's 4 weeks of training. If you like to take part in this training, you can always register. You can just contact me, and then you can start join the class. But for this one, you're doing using Tinkercad. So for Tinkercad, think of something that you can be able to do. Games are a good idea, and also couple of other projects that you can do. Also, there are a lot of ideas. So come up with your idea, and then would be assigned with specific uh, mentor, and with your mentor, you keep on discussing if that project is realizable or not. Don't be too ambitious, or don't do something very easy. So, Dave, if you can send the PDF, I can discuss this in the group. Okay. The PDF has been sent out. Okay, as you can see, for example, group one is these people, Isaias, Aisha, Haila, Manuel, and a couple of you. So the Telegram group for each of the groups have been mentioned here. And the teaching assistant is also here so that you can click and join the class. Okay. You can join your Telegram group. So by default, the group leader is the one which is made in yellow. But uh, if this person would like to change, or if you guys would like to change, or this person is missing, you can always change the group leader. Okay, so we have 5 groups. Okay, so we have 5 groups, and each of the assistants would be joining in your Telegram group to support you in your discussion. Yeah, so start joining your Telegram group. Nati, go ahead and send out the attendance for today. Um, you guys start to join and start discussing about your project. Hello all. So if you haven't heard me say, what we're doing is we've sent out a group form for each of you. So please go ahead and start joining your specific groups. And mentors also are joining to your specific groups. Mentors, please join to the assigned specific group that you would start to actually uh, to mentor your group. So this for in your specific group, as I've said it a bit earlier, the ones that are highlighted with yellow, that is a group leader. So you can choose a different group leader based on your agreement with the group. We just assigned it by default. You can always go ahead and change it. So start the discussion. Tomorrow, when you come, we require one idea. For you to come up with one idea, you need to finalize what you're going to do, okay? And then tomorrow, you're going to dedicate the time in the project development only, not in the ideation. So when you come up tomorrow at 5 p.m. GMT plus 3, make sure that your idea is ready and ready to be executed. All right? So it's important that you do that. Um, yeah, that's it. So let's keep on discussing on the Telegram group and also in the chat section here until we have the time. So make sure to fill in the attendance. Attendance has been sent out in the Telegram group, okay? Maybe let me pin the attendance so that you can, it's already pinned. So you can work on the attendance. Okay. So last reminder before we completely move on to the project development, please go ahead and start sharing what you learned, what you've been doing for like 5 minutes. Let's have a social media time on any of your preferred social media. When you share, please make sure that you actually mention us, like Infnova Technologies. If you just say at Infnova, then definitely we're going to look at what you've posted. So please make sure that you send it out in the in any of your preferred social media. Let's do this for 4 minutes, so that we need to support even more and more groups of students from around the world. So I'm going to put 5 minutes, 4 minutes timer. Let's start sharing on our social media. Okay. So just repeating what I said now. Yeah, there is no quiz today. You guys asked for a quiz. So someone also said, please someone answer how is the group form. So the group form is for some of you who have already filled in the group form previously. So if you haven't filled in the group form, please contact one of the assistants, maybe Dave or Nati or Kareset, and they will be supporting you in putting you in one of the groups. Most importantly, write this to Dave. Okay, so what I've been saying is for the next 3 minutes, we'll be using this for our social media time. So based on the link that I've sent, please make sure that you join us in any of your preferred channels, whether it's YouTube, Instagram, TikTok, or anything. I have sent the link. Please go ahead and join us, and also take a screenshot of the training, or maybe anything that you like. You can post it in your social media and tag us with at Infnova Tech. When you start to write Infnova at Infnova, then definitely you'd find us in any of the social media, so that we can keep on growing and growing what we're doing for different places. Also, you can drop the link tree that I have sent so that students, professionals from around Africa would be joining us to grow the community, to grow all the things that we can do to innovate around the African ecosystem. Okay, we're remaining with 1 minute, a bit above 1 minute for the social media time. So please go ahead and share what you've been learning. You can take a screenshot of the class or also one of the circuit that you've been doing and go ahead and post it on LinkedIn, post it on Facebook or Instagram and tag us saying at Infnova, or you can mention us if it's on Instagram, so that we keep on developing this community, where this community is going to be very vital as we progress on the innovation around Africa. We have a lot of things that we do. Make sure that you connect to us. We are going to come with exciting trainings, even with more international partners. So stay tuned with us to benefit from a lot of opportunities that could come along with this. Okay, last 30 seconds for you to share a screenshot of what you're doing, the electronics, the coding, or even just a screenshot of the class on any of the social media, LinkedIn, Facebook, Instagram. Make sure that you do this. We really appreciate it. Thank you. Okay, let's keep on going to the project. Hello, everyone. So I see that a lot of you are discussing in your group. So keep on discussing what you're doing, and we'll keep on chatting in the group. Okay. Have a good night. Make sure that you have a crystal idea when you come for class tomorrow. See you tomorrow. Au revoir.